Hey everyone. So in this video, I wanted to take a look at a limit question where we have a rational function and we see that the limit is approaching negative infinity. I think that these types of questions, it's really possible to make an error in your sign. So I'd like to go over a video explaining exactly how we can deduce the proper sign and the approach to solve this question. So to start off, with any other rational limit, we're going to approach it the same way, where we're going to multiply or we're going to divide out the highest degree from the denominator. And we can see that the numerator and the denominator, they both have the highest degree of 1 because the highest term of the denominator is power of the numerator is power of 1. The highest term of the denominator is power of square root x squared, which is just going to reduce to power of 1. Right? So we'll start here and we'll do times 1 over x of the numerator. So we're just dividing out an x, and we got to do the same thing to the denominator. But just remember here that, since we have an entire square root over the entire denominator, if we were to just divide out x, well, we can't reduce the powers of inside the square root if it's just x, right? We need to have the x in terms of square root, right? So let me explain that a little bit better. You can see here, if we try doing 1 over x times the square root of 25x squared plus 4x, this isn't going to get us anywhere. We can't reduce this. But notice if we had the square root of x squared, well, it's the same thing, right? But now, because they're both underneath square roots, we're able to reduce the power terms inside of that radical. So the key here to this question here is that notice that since we have x is approaching negative infinity, well, this means that x would be equal to the negative square root of x squared, not the positive. So when we're dividing out this highest degree, this has to be negative x squared, right? And this is the key to this question here. And let me just throw that off to the side a little bit lower. And I'm even going to highlight it because this is the most important part of this question, to realize this. And now, well, you can solve it just like any other limits question, right? And this is fairly simple. So we've got, in the numerator, this will reduce to 3 minus 3 over x divided by, the negative's going to stay on the outside. And now we've got 25, and we're multiplying everything now inside of the square root, right? So x squared is going to divide out. So it's going to be x squared divided by x squared, which is just 1, plus 4 over x times x squared is just going to be 4 over x, right? Okay. And we can actually evaluate this limit now. There's nothing stopping us from evaluating this. So we get 3 minus 3 over negative infinity. That's going to be 0. So we get 3 minus 0 over negative square root of 25 plus, and then 4 divided by negative infinity. It's going to reduce to about 0 plus 0. Okay. Let's scroll down a little bit. And we can see that this is going to be 3 divided by negative 5, or negative 3/5. And this would be the answer to our limit. Now, still might be a little bit confusing, so I'd like to approach this question now with a slightly different method, and we're just going to use a substitution now. And maybe this will make things make a little bit more sense if the x is equal to negative square root of x squared. If that's a little bit fuzzy, then maybe using a substitution would be a way that would work for you. It's just a little bit of extra work, I would say. So instead of doing that, let's now say that let's let 1 over x be equal to negative y. And you'll see why we'll do this in a second. We're trying to get rid of this negative infinity, and let's just make things positive numbers. And you'll notice that we let this be equal to negative y, because as x approaches negative infinity, well, let's think of what y would approach. Well, y would approach, 1 over negative infinity, that's going to be 0, right? But from the negative side. So negative y would be equal to it's approaching 0 just slightly, right, from the positive side, which means that this would be 0 from the right-hand side. Let's graph this out just to make it make a little bit more sense, right? If we had, and just to put this in terms of, I'm going to graph our expression 1 over x equals negative y, and I'm going to graph it in some terms of something that probably will make a little bit more sense, something that you've seen lots of times: a normal y-axis, a normal x-axis. Well, using a normal y-axis, we know that y is equal to negative 1 over x, right? So negative 1 over x is going to look something like this. Right? This is a very approximate graph, but we know it looks something like this. You'll see as x is negative infinity, you can see here, we're approaching a value that's just above 0, right? Because this is 0 right here. You can see that our values here, we're approaching 0, but we're approaching 0 from the positive side, right? This is negative 1 over x, for clarity. So as x approaches negative infinity, y would approach 0 from the positive side. So now that we've made that little substitution, let's put our limit in terms of y now instead of x. Well, we just said as x approaches negative infinity, y will approach 0 from the right-hand side. So now we've got 3, and we have an x. I'm just replacing the x's now for an expression in terms of y. If 1 over x is negative y, that means that just x would be negative 1 over y. Negative 1 over y. Right? And that's just rearranging from our expression that we created. 1 over x equals negative y. We'll do minus 3, and now in our denominator, we have got square root of 25 times negative 1 over y squared plus 4 times negative 1 over y. All right, let's simplify this now. This is going to be equal to the limit as y approaches 0. From the positive side, we've got negative 3 over y minus 3 divided by, this is going to be the square root of 25, and then this negative squared is going to be positive, and then we'll have times 1 over y squared. And then this is going to be minus 4 over y, right? And this is just simple multiplication right now. Right? Looks good. Okay. And now, what we're going to do, same approach now, we're going to try to multiply out our highest degree, right? Because we can't divide by 0. So let's multiply everything, and you'll see it's similarly to the first time. Highest degree is still going to be 1, but we're going to be multiplying now instead of dividing by 1 over. So we'll do times y times, and then same idea, times the square root of y squared, right? And this is fine. We're working all with positives now. Y is approaching 0 from the positive side, so this is going to, y will just be equal to the square root of y squared, right? So our numerator is going to be, okay, limit as y approaches 0 from the right, and that's going to be -3 minus 3 times y. And we've got a big radical in our denominator, and this is going to be 25. Our y squareds will cancel out, minus 4 times, and then our y squared divided by y will just be y. And we can evaluate this. This will be -3 minus 3 times 0 is 0, divided by the square root of 25 minus 4 times 0 will be 0. And then finally we'll get -3 divided by, and then we got square root of 25 is just going to be 5. So you can see we resulted in the same number. The limit would be equal to -3/5. So just to recap, the first time that we solved it, we kept everything in terms of x, divided out the highest degree, but the key to remember was since x approaches -infinity, we had x is equal to negative the square root of x squared. And we needed that expression there because we have a big radical in the denominator, and we need to be able to reduce that. So with that expression, you can solve it pretty directly, right? Pretty much just one step, and then you're good. If you don't have any confidence that you're going to do this correctly, then let's do a quick substitution. We can choose 1 over x to be equal to -y. And the reason that we did that was because as x approaches -infinity, y approaches a positive value, or 0 from the positive side, right? And we sketched that out with a quick little graph there, right? Just for extra clarity. And then we just took our expression that was in terms of x, we created a limit that was in terms of y, we simplified it, and then we had a limit that was also a rational function, right? But it was only in terms of positive values essentially, and it was a lot easier to figure out what the sign was. So then we solved that by multiplying out the highest degree, and then we simplified, and we resulted in -3/5. So I hope this video was helpful. If it didn't, then leave a comment and hopefully I can explain better.